The dimensions of the quantities in one or more of the following pairs are the same. Identify the pairs. So we have to identify if these two are having the same dimensions. Okay, so first we can take option number A. So torque. So torque is defined as R cross P. Tau vector is defined as R cross F. Sorry, R cross F. So this dimension of torque will be dimension of force into dimension of distance r. So this will be force is mass into acceleration and r is the distance. So this will be m l t power minus 2 into l, or this can be written as m l square t power minus 2. Okay, so that's the dimension of the torque. Now what about work? Work can be written as force into displacement. Now force, dimension of force is m l t power minus 2 and dimension of distance is l. So I can write it as m l square t power minus 2. Okay, now you can see that the dimension of work is same as the dimension of the torque. Now option A is correct. Now what about option B? Angular momentum and work. Angular momentum, the definition of angular momentum is r cross p. Okay, so the dimension of angular momentum L is equal to dimension of r into p is mass into velocity momentum. So I can write r is the distance, so this is L and m is m and v is L t power minus 1. So I can write it as m L square t power minus 1. Okay, now what about work? We have already found the dimension of work, so we can see that these two are not equal, so option B is wrong. Now what about option C? Energy. Energy is work done, so that is force into displacement. Okay, so we already found the dimension, that is m l square t power minus 2. So that's the dimension of energy. Now Young's modulus is defined as stress by strain. Stress is force per unit area and strain is change in length divided by original length. Now I can write it as F by A into L by delta L. Okay, now L by delta L is a ratio, so it doesn't have any dimensions. So I can write dimension of Young's modulus is the dimension of force per area, and we know the dimension of force is ml t power minus 2. The dimension of area is L square. So we can cancel the L from both sides. So this will be m L power minus 1 t power minus 2. Okay, now you can check it with check the Young's modulus with the energy. Okay, so both the dimensions do not match, so that is also not correct. Now the third is light year and wavelength. We know that wavelength is the distance traveled by the wave in one time period. Okay, so its dimension is length. Also light year is also of the dimension of length, so it is the distance traveled by the light from earth to sun. Okay, so that's light year, so that is also of the dimension distance or length. So option D, both the physical quantities have the same dimension. Okay, so hope you understood the solution. Thank you. Sorry, I have made a mistake. Light year is defined as the distance traveled by the light in an year. Okay, distance traveled by the light in an year. So that's the definition of light year. So both light year corresponds to distance and wavelength also corresponds to distance. So option D is correct. Option A and option D are the correct options. So thank you. Hope you understood the solution.